This video is about similarity and proportions. Now in problem number 9, these two small triangles are not similar to each other. However, there is a proportion that we can make out of the segments. Now first we're going to need to know the length of this missing segment right here. Luckily we have the whole number of 52. So if we just subtract 52 minus 16, we can easily find the other piece. Alright, so this piece right here must be 36. So, the fact that these angles are marked the same means that they are congruent. So this is an angle bisector. So, we can use something called the angle bisector theorem. Now I'm going to exaggerate this angle bisector and just stretch it out to give you the impression that we are dividing this image into two sides. So what I can do is I can make a fraction out of this side of the line, and I can make a fraction out of this side of the line, and those fractions will be equal. In other words, these segments are proportional. So for example, I could do 36 over x. Okay, I did those two. And that would equal 16 over 20. Now these are both divisible by 4, so I always like to reduce when I can. Smaller numbers are easier to work with. So this is going to give me 4 over 5. After that, it's time to cross multiply. So I will get 4x equals, and then I have to figure out what 5 times 36 is. So that is 180. And then we will divide both sides by 4. And that turns out to be 45. So that is going to be the final answer for problem number 9. Problem number 10 is very similar. Again, these angles are marked congruent, so that tells me that this is an angle bisector. And I'm going to exaggerate it again to make it clear that I'm going to make a fraction out of this side of the line, and I'll make another fraction out of this side of the line. So that's going to give me 12 over 8 is equal to 3x plus 6 over 14. Both of these are divisible by 4, so that's going to give me 3 over 2 equals 3x plus 6 over 14. Okay, cross multiplying, I'm going to multiply these two together. So I'm going to do 2 times 3x plus 6. And then I'm going to multiply these two together. And that's 42. So a little distributive property here, and I have 6x plus 12 is equal to 42. Subtract 12 from both sides, and that's going to be 30. So I have 6x is equal to 30, and then divide both sides by 6. And we get x is equal to 5. So that will be the final answer for number 10. For number 11, I see all these tick marks, and these tick marks are causing L, N, and M all to be midpoints. It's congruent on either side, so these are all midpoints. That means that each of these is a mid-segment. All right, and so each mid-segment is going to be half the length of the parallel side. All right, I feel like I should do this more boldly. So this is a midsegment, and it will be half the length of this. Okay, similarly, this is a midsegment, and it will be half the length of this. And this is a midsegment, and it will be half the length of this. Okay, so AC is 14. So we're told that this is 14. All right, so since M is the midpoint, that means that AM is 7 and MC is 7. Okay, and LN is also 7. All right, really all three of these segments are half of the parallel side. So LN is 7. All right, anything else over there? No. Okay, NC is 6. So NC is 6. That means that BN is also 6. All right, that means that BC is 12. All right, that's the whole thing is going to be 12. And of course, LM is going to be half of that. So LM is going to be 6. So they asked us to find LM. LM is 6. Okay, AB is parallel to what? So let's see, AB, that's this red segment, that's parallel to MN. NB is congruent to what? Okay, NB is 6. NB is congruent to NC. It's also congruent to LM. All right, all three of these are 6. So NB is congruent to NC and LM. Okay, triangle LMN is similar to what triangle? Okay, LMN. Notice the triangle LMN is this small yellow triangle in the middle. That is going to be similar to the large outer triangle. All right, the inner triangle is similar to the outer triangle in this situation. Okay, so it's going to be similar to triangle. All right, now let's try to match it up though. All right, they gave us LMN, and look, angle L is going to correspond with angle C. All right, I don't know if you can see it, but there's a parallelogram right here. Maybe I can highlight it. In my mind, I'm seeing this parallelogram that's going like this. Okay, and these are opposite angles of that parallelogram, so those are going to be congruent. Okay, so L and C are going to be corresponding. In the same way, angle N and angle A are going to be corresponding. Okay, all right, so L is going to correspond with C, and M is going to correspond with B, and N is going to correspond with A. So, triangle CBA. For problem number 13, we are given that LM is 3x plus 1. So this is 3x plus 1 right there. And BC is 10x minus 6. So this is 10x minus 6. Now again, this is a midsegment. The midsegment is half the size of the parallel side. So if I double the midsegment, if I do 2 times 3x plus 1, that should equal the parallel side. That should equal 10x minus 6. Again, I know this is a midsegment because of the tick marks, which indicate that M is a midpoint and L is a midpoint, same on each side. Anyway, back to the equation. If I do the distributive property, that will be 6x plus 2 is equal to 10x minus 6. Subtracting 6x from both sides leaves me with 2 equals 4x minus 6. Then if I add 6 to both sides, that gives me 8 is equal to 4x. And then when I divide both sides by 4, I get x is equal to 2. All right, so we were supposed to find the value of x and the length of BC. Okay, so I found x. Now I'm going to find the length of BC. All right, when you write BC without the segment symbol, it means the length of BC, by the way. So we have an expression for that length. It is 10x minus 6. So I'm going to put 10x minus 6. But now we know that x is 2. So that's going to be 10 times 2 minus 6. So that's 20 minus 6. So that is 14. Okay, so BC is 14. So these are the two things that we were asked to find. So that's it for number 12. Okay, looking at number 13. All right, Susie glances at this and says, hey, LM must be half of 14. So it is 7. Okay, she goes like this. LM has to be 7 because it's half of 14. But this is wrong. The question is, why is this wrong? What is she thinking? Well, looking back at the previous problems, this LM, for example, this was a mid-segment. It's a midpoint connector. We knew because of the tick marks. So that's why the midsegment is half the length of the parallel side. But looking at number 13, not only are there no tick marks to show that these are congruent, but we have numbers here, 4 and 6. If L was a midpoint, it would be 6 and 6, or 4 and 4. So because L is not a midpoint, that means LM is not a midsegment. So this the theorem that says the midsegment is half the parallel side will not apply to this problem. That's what she's doing wrong. All right, so here I've written a couple of sentences repeating what I just said. All right, so now we're supposed to find the length of LM correctly. So since this is not a midsegment, I'm going to have to draw these triangles separately and do new over old equals new over old. So I'm just going to draw the small triangle and the larger triangle as two separate triangles. So here I've drawn the two triangles separately. We're supposed to find the length of LM. You know, I should probably label these sides. So this is A, L, M. And I know that AL is 4. And LM is the thing I'm trying to find. So I'm going to go ahead and put an X on that. Now the larger triangle, this is triangle A, B, C. I know that side BC is 14, so I'm just going to go ahead and put a 14 on that. And what about AB? I see the 4 and the 6. Together that's 10. So AB is 10. I see I have corresponding sides here, so I should be able to easily make a proportion. So I'm going to consider this to be the new triangle. And I'm going to consider this to be the old triangle. Just because I like to say new over old equals new over old, and it's also nice for me when the variables are in the top. So when I do new over old, okay, that's going to give me x over 14. And then I'm going to do new over old again, so this time that's going to be 4 over 10. Now both of these are divisible by 2, so that's going to give me x over 14 is equal to 2/5. If I cross multiply, it's going to look like this. So that's going to give me 5x is equal to 28. And then it's time to divide both sides by 5. So this will be a decimal. So I hope I didn't make a mistake. Sometimes you get a decimal. That's 5.6. So hopefully I haven't made a mistake. All right, we need to find the values of x, y, and z. Now, when I go to find the value of x, if I want to, I can use a shortcut called the side splitter theorem. You can use the side splitter theorem when you're just dealing with values on the side of the large triangle. You cannot use the side splitter theorem to find y. Okay, the parallel sides cannot be used in the side splitter theorem. So I'm going to definitely ignore that right now. But the side splitter theorem says that x over 10 should equal 12 over 8. Now, these are both divisible by 4. So if I divide by 4, that's going to give me x over 10 is equal to 3 over 2. And now I cross multiply. So I'm going to do this diagonal, and then I'm going to set that equal to this diagonal. So that's going to give me 2x is equal to 30. And then if I divide both sides by 2, I get x is equal to 15. So that's one of the 3 values that I was supposed to find. All right, now let me switch colors. So now I need to find, I think I'm going to skip over and find angle Z next. You know what? I changed my mind. I'm going to go ahead and find Y next. So I mentioned that you can only do the side splitter shortcut when you're not dealing with these parallel sides. So since y is one of the parallel sides, I need to do it the long way. And the long way is just to draw the small triangle and the large triangle separately and set up a proportion in the form new over old equals new over old. So that's what I'm going to do now. So here I have drawn the triangles separately. So let me label what I can. First, look at the small triangle. This is clearly x right there. You know what? I should do this in red for my OCD people. Okay, so this is clearly x, and this side right here is going to be 12, and this side right here is going to be y. And inside here I have 39, and here I have 8z. Okay, now it's time to switch to the large triangle. Now this side over here is 18. All right, now I have to be a little bit more careful. This side over here is 20. I have to do 12 plus 8, so this side over here is 20. All right, now this side over here is 10 plus x, or x plus 10. Okay, and this angle right here is 53, and this angle right here is 39. So, this is what I have to do to find y and z. There's no side splitter shortcut. Okay, so if I want to find y, I can start making fractions out of corresponding sides. So is there enough room for this down here? No, I'll just put it right here. So I can go y over 18 is equal to 12 over 20. Now, both of these are divisible by 4. So that would give me y over 18 is equal to 3 over 5. And then I would cross multiply. So along that diagonal, I have 5y. Looking at the other diagonal, that is 54. And then I'm going to divide both sides by 5. So this is going to be a decimal. And I hope I didn't make a mistake somewhere along the way, but I'm getting 10.8. I always get a little bit nervous when I get a decimal, even though there's nothing wrong with decimals. Sometimes it means I made a mistake. Okay, 10.8. So that just leaves z. Well, for starters, we should be able to find the third side of the large the third angle of the large triangle, because we know that all the angles in a triangle have to add up to 180. So if I start with 180 and I subtract these two angles, so minus 53 minus 39, that gives me 88. So that means this missing angle is 88. Okay, now look, the corresponding angles are congruent. All right, these will be similar triangles, so the corresponding angles will be congruent. So that means 88 should equal 8z. So I can just make a little equation out of that. I can say 88 equals 8z. And then if I just divide both sides by 8, I discover that z is equal to 11. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.